Let's start with the basics. If I've got triangle ABC and I have maybe let's say X there as angle C. Then the side opposite, so remember now, the side that is opposite an angle is the side that faces the angle. So this is the opposite. The hypotenuse is always opposite to the right angle. Very important. And obviously then this other third side will be the adjacent. It is important to note though that the opposite and the adjacent will always switch based on what your reference angle is. For example, if I have angle alpha at point A, then the adjacent becomes the opposite and the opposite is the adjacent respectively. So I hope you get what I'm saying there. But of course you would have learned about this thing called SOHCAHTOA. All right? And there are two things to this. The first thing that you need to note is that we use these ratios, sine is opposite over hypotenuse, cos adjacent over hypotenuse, and tan opposite over adjacent. We use them in one of the two cases. One case is you are given two angles and a side. Or you have two sides and one angle. A situation of two angles and a side would be where one angle is a right angle and maybe let's say this one is 65 and then maybe you are given this side as a 4. So that's what I mean by two angles. It's the right angle and another angle. So you should be able to use the three ratios, sine, cos, and tan, to solve this triangle. In other words, to find all unknown sides and angles. Obviously, because it's a right angle triangle, Pythag is still applicable. So you can't go without using Pythag. You got to use Pythag still. All right? Pythag would say the square of the hypotenuse is equal to the sum of the squares of the other two sides. Then the other one, that is two sides and an angle. So if we tell you this one side is 4, this other side is 3, and maybe we still give you another angle 65. No, actually not that. We said two sides and one angle. So that one angle is a right angle. So here a classical question again, solve for the triangle. In other words, find the unknown side. The unknown side here is the hypotenuse. And those of you who know this thing called Pythagorean triples will figure it out that the hypotenuse has to be a 5. But now to find the angles, you need to decide again, are you going to go opposite over hypotenuse if this green angle or the angle I'm circling in right now is your reference angle? It's really up to you, but these are grade 10 basics. When you're at grade 10 level, you primarily dealing with right angle triangles as far as trigonometry is concerned. So it is very important that you are able to use the trig ratios to either find an unknown side or an unknown angle. So maybe let's just do a quick recap in each case. So let's say this is triangle PQR. And let's assume maybe the question is asking for side QR. If you're going to find side QR in this scenario, it's important to note that one useful angle is 65. So the side 4, labeled 4, is your opposite, and the side QR is your adjacent, right? The ratio that has the opposite and adjacent is tan. So we should actually go tan 65 is opposite, which is a 4, over the adjacent, which is QR. Now, because you are solving for QR, which is in the denominator, it is important to also note that QR will be 4 over tan 65. There, it's your basic knowledge of algebra there. Then you can just press this the way it is in your calculator. Of course, your calculator should be in degree mode. In the case of this situation where you are not given any of the angles, let's call this angle X, and you have to find the angles or solve the triangle. Again, you can actually use any of the three ratios. You can use sine, cos, or tan because you basically know all the three sides in this scenario. So for argument's sake, I can go sine x is equal to the opposite is a 4, the hypotenuse is a 5. And I want to solve for x. At this stage, you should all be aware that to solve for x, you got to take arcsine of the ratio 4 over 5. And this is what you call shift sign in your calculators. Do I have my calculator here? I do. So if I go shift sign of 4 over 5 and I press equal to, I get a 53.13. So that becomes your solution in this instance. That's how easy it is. That's how basic it is at grade 11. But when it comes to grade 10, when it comes to grade 11, you add on to this, right? You learn about the sine rule, you learn about the cosine rule, you learn about the area rule. And I want to chat a little bit about that and just explain a few conditions for you. So if we start, for example, with the area rule, I need you to be aware of the fact that the area rule only works in a situation where you've got a side angle side situation. Remember congruency, side angle side. So this angle must be included. All right? So if this is triangle ABC, then the area rule says to find the area of this triangle, you will go half AB times BC sine of the included angle, and that is angle B. And so I want to be very clear. Please, you can only use this rule when you've got a side angle side situation. If you do not have that, you cannot use the rule. You probably then need to use other given information so that you have your triangle in this format. So very, very important that you are aware of this. Then the second rule, right, is the sine one. So the sine rule. And I want to show you again here how this one goes. With the sine rule, there are two cases, okay? It will work if you have a side angle and an angle given, or if you have two sides and an angle. Another important thing to be aware of with the sine rule is this thing called the ambiguous case. And I think I'll spend some time illustrating this. But let's just quickly recap what the sine rule says. So if I've got triangle PQR, and I'm going to use different letters deliberately here, right? Remember how we name triangles. The side opposite to angle P can be labeled by the small letter P. The side opposite to angle Q, we can use the small letter Q. And the side opposite to angle R, we can use the small letter R. All right, that's how we name triangles. So the size of a triangle at least. So the sine rule then says, well, the sine of angle P over side P is equal to the side of angle Q over side Q, and that will also be the same as the sine of angle R over side R. And remember, you can equivalently flip all this around, okay? If you are looking for a side maybe of a triangle, then this is the format which you can use. All right. So this is basically the long of and the short of it. But what is also important with the sine rule is to watch out for what we call the ambiguous case. And I just want to give you an illustration of that, like how to be aware of the fact that you are in the you are dealing with the ambiguous case of the sine rule here. So the ambiguous case, I don't really have much time to obviously illustrate these things thoroughly. So what I will do, I will just give you a summary of when or what to watch out for in a case of the ambiguous case. So if you are given a triangle, right? So pay attention, please. This is the ambiguous case of the sine rule. Let's write that. So this happens if you have a triangle okay. I think we are back. So let's say I've got triangle PQR. Triangle PQR. And watch now, very, very important. Pay attention to this. So what is given in this case is an angle, right? So I am told that angle P is 115 degrees. And then let's say, or maybe not 115. I just want to present a perfect case for you here. Sorry about that. Yeah. And do I want PQR? Yeah, it's fine. That's okay. So remember, this will be small letter q, small letter p, small letter r. So let's say angle P is said to be 38.6 degrees. And then we are told that the side R is some 32. And the side P is 22. So it is very key to note that the small letter p is the side opposite to that given angle. So whenever the side opposite to the given angle is shorter than one of the other given sides, then you must expect an ambiguous case. In other words, it's possible that we have two triangles under the given conditions, okay? So sometimes the examiner is in a very good mood and they will go like, well, find angle Q or angle P where P is an acute angle or it's an obtuse angle. So once they specify that it is an obtuse angle, it typically suggests that you've got an ambiguous case. So how do you get that obtuse angle? You will have to first find your acute angle and then you go 180 minus the acute angle. So that's how you'll work around that. Cool. In fact, maybe let's just take an example to illustrate this. So I'm given angle B is equal to 43 degrees. The side C is 12 and the side B is 9. So remember, the side B is the side which is opposite to angle B, which then means I have the ambiguous case because this side B is smaller than C. So when I solve here, all right, when I find what are they asking for? They are asking for angle A. So I've got to find angle A. I've got to be aware of the fact that angle A can either be acute or obtuse. And I want to draw this for you so that you see exactly what I mean. So the given angle, namely angle B, 43 degrees, will be somewhere there. And then the other side, namely C, will be there. So B, which means then I'll have point C somewhere here. So watch this now. This is the important part. It's possible that C could be here and this side of 9 could be there. But another possibility is that C, or rather this 9 could be there and I could have point C there. So this is exactly what we are talking about, and I hope you are noting that. So which means then A could be this angle here, or it could be that angle there. All right? So it is quite important that we are all aware of this, that actually the given scenario presents two possible triangles. But like I said, recently I've seen examiners being quite nice and kind. They tell you whether to find, whether you should find the acute or the obtuse. So that shouldn't be a big deal, right? Cool. Now, the cosine rule, on the other hand, this one will require two conditions. You either have strictly side angle side, and then if you have side angle side, obviously you will look for the third side. So if your triangle is like that, let's try and make a better triangle. So you have side there, you have an angle and a side, then you can use the cosine rule to find that third side. Alternatively, you have three sides given. So you know that side, you know that side, you know that side. And all you have to do is to just find one angle, one of the angles, again, using the cosine rule. So I'm going to try and illustrate this, how you can do it. There are easy questions, level 1 questions, which are straightforward, where they just ask you, determine the area of this, etc., etc. But then things can get a bit complicated when they start asking, prove that this is equal to that, and those kind of things. So, which one am I going to start with here? I want to give you an illustration of what I'm talking about. Let's see. No, let's rather go to that question. I think there's a question I had put up here. Yeah, here it is. Here it is. So in triangle ABC below, we've got AC is equal to 2x, BC is 16 minus 4x, angle C is 120, and B is theta. We want to determine the area of triangle ABC in terms of x without the use of a calculator. Because of that, it should become obvious that we will have to use the area rule, And what does the area rule state? The area rule says, if you're going to figure out the area of this triangle, first of all, check that you've got a side angle side situation. And if you notice, we do have a side angle side situation in that we know the side AC is a 2x. We have the angle in between, and we have the side BC, which is a 16 minus 4x. So it is quite nice and straightforward that to find the area here, we will just go half and then the 2x multiplied by the 16 minus 4x, and we will go sine of 120. Now, obviously, the next thing to do is just to do your basic math here. I'm going to start off by multiplying these two, the half and the 2x. That will just give me an x. But now, the x has to be multiplied by 16. Let me just do this step by step so that I don't lose anyone. By the way, sine 120, the calculator can do that. If I remember, I think it's a sine 60. The sine 120 will reduce to a sine 60. And that's equivalent to cos 30, which is square root 3 over 2. So you can actually just get a replacement for sine 120. It should be square root 3 over 2. Now, please, I've seen students do one common mistake, and that's why I'm going to pause on this one, where students multiply their x by everything here, and then they want to multiply their x by that. Please take note, you can't do that, right? Because this thing here is a product. It's a product of three numbers. You are multiplying x, you are multiplying that by 16 minus 4x, and you are multiplying that by square root 3 over 2. Now, think with me. If I've got 3 and I multiply it by 2 and multiply that by 4, I never multiply 3 by the 2 and multiply it by the 4 again. I never do that. Rather, I will multiply 3 by the 2 to get a 6, and then I multiply by 4, then my answer is 24. So you have to use the same approach here, okay? You got to use the same approach. So if you're going to start with 16 minus 4x, so you're going to start by multiplying 16 minus 4x by x, then don't multiply x again by the square root of 3 over 2. So, in fact, one of the little things that we always suggest is always have numbers in the front. So, you probably want to rewrite this as square root 3 over 2 times x into a 16 minus 4x. Once again, I can do this because multiplication is commutative. In other words, the order in which you multiply numbers does not matter. That 3 times 2 times 4 will give me the same result as 4 times 3 times 2. Okay? So just beware. That is why I can do this. Then, finally, we've got square root 3 over 2 into what? 16x. And then I just want to be deliberate here and only multiply the x so that you see what's going to happen next. And that's 4x squared. So what have I done? I've only distributed the x. You could have even done the number, but I just want to dissect this, break it down so that you see actually what is happening. Now, finally, when I multiply the square root of 3 over 2, which I have said you could have done, I want you to note that you will now get 8 square root 3x minus 2 square root 3x squared, okay? And yeah, that's the area in terms of x. So if you look at the follow-up question, matrix, this is your calculus, for which values of x will the area of ABC be maximum? You obviously need to find the first derivative. When you have found the first derivative, you will then equate it to 0 and solve for x, and just like that, you will have the x value which will make this thing a maximum. Fortunately, you're only going to have one such value. Right. I want to try and get another question on 2D trig so that you can actually see how this all plays out. This one is 3D. But it's fine. It's all riders. So let's do it. Let's do it. So let's take this one. I'm going to try and zoom so that we all see this diagram and the questions presented. I'm not going to focus more on the mark allocation. It's all what? It's 3, 3, 3. So 9 marks for grabs here. All right, so let's see what's happening here. B, C, D are points in the same horizontal ground. So this is like on the floor. And then AB is a vertical pole of length 4 meters. BD is 5.6 meters. And CBD is 115. And the angle of elevation of A from point C is 43 degrees. Okay. So we have to calculate the length of CB, and then we calculate the length of CD, and we find the area of BCD. So let's see what's happening here, right? CB is this side here. Now, earlier on, when I was revising right-angled triangles, I told you that to solve a right-angled triangle, you either need 2 angles and a side given, or 1 angle and 2 sides given. So if you look at this triangle, which I have highlighted, which is triangle ABC, surely you have a situation of 2 angles and 1 side. So you have the 43 degrees, the right angle, 90 degrees, and the 4 meter. So what are you looking for? You are looking for BC. I will obviously then use the given angle 43, and I want to find what BC is. BC is my adjacent, and I'm given the opposite, which is AB. So that means from the SOHCAHTOA, remember I said right angle triangle, do not even bother yourself a lot. Just go for the SOHCAHTOA. So what I will then do is I will go, maybe let's write it down first, SOHCAHTOA. Because I have the opposite and the adjacent involved, I have to use the tangent. So I will start off by saying in triangle ABC, the following is happening. Tan 43 is equal to the opposite, which is 4 meters, over CB, the side I am looking for. And we know since CB is in the denominator, making it the subject of the formula will lead to 4 over tan 43. Let's just quickly see what this is on the calculator. 4 over tan 43, that's about 4.29. So we know this side is 4.29. Maybe let's round it off to 1 decimal place. Yeah. Then, of course, in your case, if they do not specify, you round off to 2 decimal place as standard. I think there's that instruction that says, unless otherwise stated, you must round off to 2 decimal digits. So we know BC now is 4.3, right? So we have found this. Let's maybe add that to the sketch. It helps, 4.3. Then we have to calculate the length of CD. Now, I want you to watch here. To calculate the length of CD, you need to change your focus now. You need to switch from that right angle triangle and come to this one triangle, of which they said it's on the horizontal. It's on the ground, this triangle here. And I want you to notice that the information in that triangle is literally side, angle, side. Now, there's no need for you to guess here. There's no guesswork where you're going to try and figure out which rule should I use. We have made it very simple and straightforward for you. You have a right angle triangle, SOHCAHTOA. You've got side, angle, side, area rule. You've got side, angle, angle, or side, side, angle given. You use the sine rule. Otherwise, another option is you can use the cosine rule, and this only happens if you are given a side, angle, side, or a side, side, side. So clearly, based on what we have and the question at hand simply requires us to calculate the side, right? So we have to use the cosine rule. The area rule cannot help us to calculate a side unless the area is given and we have to find as one of the sides, of course. Okay, so let's just go straight for the cosine rule here. In this context, I always advise that please just tell us which triangle you're working in, so that the marking is also nice and easy. So in triangle CBD, CD squared is equal to, what's going to happen? You're going to square the 4.3, and then you're going to square the 5.6. Then you say minus 2 times 4.3 times 5.6. Then you, because it's the cosine rule, we have to go cos 115. Of course, guys, you don't have to worry about memorizing these rules. They're always given in your information sheet. Now, we just plug and play into the calculator. And to avoid the error of rounding, I would suggest that you as well take the square root. CD is going to be the square root of this whole thing. So, for improved accuracy, you may just want to do this. You might as well do this. That's cos 115. There we go. So let's hold this in the calculator and see what we've got here. 4.3 squared plus 5.6 squared minus 2 times 4.3 times a 5.6 cos 115. Let's see. On my side, I get something like an 8.37, which we can round off to an 8.4, correct, to one decimal place. Now, does this answer make sense? Well, tell you what, 8.4 would make sense because it is opposite the biggest angle in this triangle. So one way to check your answers when working with triangles is to actually check whether the biggest angle is opposite the longest side and the smallest angle is opposite the shortest side. I can bet with you now, since CB is 4.3, we expect angle D here to be the smallest angle in that triangle. Maybe I must be specific and say angle CDB. That angle here will be the smallest angle in this triangle because it is opposite the shortest side in triangle CBD. All right? And so equivalently, the angle 115 is opposite the longest side, which is 8.4. So whenever you are not sure, you do a calculation and you are not sure whether your answer is correct or not, just check. Do you have the shortest side opposite the smallest angle, and you have the longest side opposite the biggest angle? If that is the case, you are safe. If that is not the case, you have to question your calculation. You got to ask, what went wrong in my calculations? Right. Finally, we want to find the area of triangle BCD, which is the same triangle which we were working in now. So this one is quite simple because we already have side angle side. So the area is going to be half 4.3 times 5.6, and the included angle, so I'll take sine of 115. And then all you got to do, weigh this whole thing in the calculator. And let's see what we get here. 0.5 times 4.3 times 5.6. And I'm going to go sine 115. I get something like a 10.9. And because they've given you units, it's proper to indicate that these are square units. So in particular, this will be 10.9 meters squared. All right, so that's basically the long and the short of the sine rule, area rule, cosine rule. The nice thing is we actually got to use all of them, except that we have not used the sine rule so far. We have only used the cosine and the area rule. Maybe let me try find one more question, excuse me, which hopefully will give us the sine rule. I can do this, but I don't want to do it because grade 11s are going to be lost now. Grade 11s don't know much about this thing called, what do you call it? Double angle and compound angles. I see a double angle there, so that's why I'm going to kind of shy away from it. Okay, let's do this one. It's quite interesting because this one is abstract now. You are doing some proving, and I know these questions often seem impossible to do. You walk out of the exam, be like, but that was so unreal. How was I supposed to do that? And I hope I get to show you, or at least after this illustration, you get to see and appreciate how easy it is to do such questions. At grade 11 level, really, it should be the easiest thing to do because you don't have a lot going on. You probably get a triangle like this. You are two-dimensional most of the time. So one of the things that you always advise is look out for the common side. You see, in this situation, BC is the common side. And I can tell you, I've not even read the question yet, but 99% chances are I will need that side BC because that is the one side that will help me to link up all that is happening in triangle BCD with all that is happening in triangle ABC. So I want you to watch out for your common sides, the shared side, the sides which the presented triangles seem to share. I want you to pay attention to those. Do not neglect those sides. So let us start with the first problem here, where we have to show that sine y is equal to 2 sine x. All right. So, oh, by the way, have we read everything? My apologies. We have not read. That's bad. Let's read quickly. In the diagram, BCD lie in the same horizontal plane. And listen to this, very, very important, right? And this is the part that I did not read, and we might need it. BD, the side BD is twice CD. Please take note of that. BD is twice CD. So look at the diagram now. CD is given as B, which means BD will be twice of that, so it must be 2B. You see, very, very important to read. You would have gone like, if you didn't read, just allow me to stress this one. Had you not read that statement, if we had ignored that statement, I promise you, we would say this question is impossible. We were going to go and try the sine rule, and then the result doesn't come out. Then we change to something else simply because we have not read. So I hope you get to see and appreciate the importance of reading the opening statements, because it's not always the case that they put all the information in the sketch. So please make sure you are safe and read, and make sure that whatever you have read is fully indicated in the sketch. All right. Now, the angle CBD is X. That one is already marked. We're good. And the angle BCD is Y. And CD is B meters. We are told that AB is a vertical tower. And to show that they have given us a right angle. And let me say this again. If they had not put that right angle, the fact that AB is a vertical tower gives you the right to indicate that this thing is a right angle. Let me say that again. Had it been that this angle here was not indicated to be a right angle, it is on you to indicate that it is a right angle. Why? Because a vertical tower will always be perpendicular to a horizontal plane. And because of that, you have to show that. So it's one of the things which, again, they do not always indicate, but they will say, and you need to know what it means when they say such. Lastly, the angle of elevation of A from C is theta. Now, let's quickly maybe talk about this elevation and depression story. So, if this is where you at, right? Your eye level is usually the horizontal. Now, if you look up, look at some object up above you, the angle which forms between your eye level and that object is what we call the angle of elevation. If you look at some object below you, then the angle which forms between your eye level and the object you are looking at is what is known as the angle of depression. So elevate, look up, depress, down. You know, some people when they say that they're feeling down, they say they are depressed. When they are not really depressed, they're just feeling down. But I hope you get the message. That's what I'm trying to say. So please don't ever get confused on this aspect of elevation and depression. That's how easy it is. All right, let's cook now. Let's do this. We wanna find, or we wanna prove that sine y is equal to 2 sine x. Now, one of the obvious things, or rather, maybe it's not obvious. One other thing which students battle with is which triangle am I going to work with? And I usually say, folk, the way this thing is so easy, man, you're gonna hit hard on yourself, because what is really happening is, look, you have a sine y in your solution. Remember, let me maybe write this question here in case you don't see it. We are actually required to prove, this is what the question is asking. We are required to prove that sine y is equal to 2 sine x. That's what we are required to do. So you have sine y. Look at y. Y is in the horizontal plane, is in triangle CBD. You also need a sine x. Guess what? The angle x is in sine CBD. I mean, is in triangle CBD. Excuse me. You need a 2. Well, we can see the one side is double the other. So this show is surely happening in triangle CBD. There's no reason for you to try and use triangle ABC. There's a theta there. Theta does not appear anywhere in what you are required to show. So I hope you see how easy and logical it is to actually deal with this type of questions. So without any difficulty, you should be able to see that, no man, we have to work in triangle CBD. Okay, based on the result we want. So what is happening there? Okay, I have 2 angles, 2 sides. Galore information is given here. Okay, so based on what is given, it does appear the sine rule will be more applicable. So I will go sine y over the side opposite to y is 2b. And then sine x, because I do need sine x, this will be over b. Just like that, we are in the money. Watch this. I multiply by 2b both sides. And then okay, sorry about that. My internet is just acting out for some weird reason. But we are back. We should be fine now. So as I was saying, if I multiply by 2b, then this becomes 2b sine x over b. And watch this. This is what every student likes to see, things canceling out. So just like that, sine y is indeed equal to 2 sine x. The result which you wanted, the result which you anticipated. So you see, when you just follow the rules, the strategies, the methods, things truly fall into place, guys. I hope you note and appreciate that. Now, next up, we want to prove that AB, which is in the right angle triangle, by the way, we want to prove that AB is B tan theta square root of 5 plus 4 cos x plus y. Now, that really looks scary, right? I mean, man, how on earth are we supposed to get that? Right? Well, guys, I have good news for you. This is the easiest thing ever. All right? Now, you see there's a tan theta, and then AB is involved. Look, that really invites us to what? To that right angle triangle. But what do I want to link AB with? Do I want to link AB with AC? Or do I want to link it with BC? I hope you all thinking BC. For obvious reasons, BC is the common side. So AC is not so relevant right now. So we're not even going to try and involve AC. So we're going to only look at AB because we are supposed to show that AB is equal to something. And we will do BC because BC is the common side. So we shift our focus. We have proved this one. So I'm going to get rid of it. If we need it, we will look at question 7.1. So for 7.2, it is important to note that in the right angle triangle ABC, no sine rule, guys, no cosine rule. You could use them, but there is no need because it's a right angle triangle. You just go SOHCAHTOA. So in that triangle, tan theta is the opposite, which is AB over BC. Now, if I solve for AB here, AB becomes BC times tan theta. Now, my job is very simple now. I need to find out what this BC is. And looking at the result, this BC surely must be some B, and it is what must bring me the square root and that kind of a thing. So we have to now revisit. We have to revisit that triangle CBD. But this time, look, there's no sine involved here in what you want. So there's no need for the sine rule. There's a square root appearing. The one rule that has squares in it is the cosine rule. So I need to use the cosine rule to find BC. And I notice that the angle which is opposite to the side BC is an unknown angle which I need to calculate by using interior angles of a triangle. So that angle will be 180 degrees minus the sum of x plus y, or the sum of x and y. That's what it is going to be. So I must be aware of that fact. Now, watch. It's about to be fun now. So please pay attention. We want BC. So according to the cosine rule, BC squared, watch this, BC squared is equal to, remember the two sides are 2b and the b. So I must square the 2b. I see students losing marks here, and I hope you see how I use brackets. I usually say brackets save lives, and I promise you, putting brackets around 2b will help you a lot. So 2b plus a b squared, you see, even if it's just one letter, but for safe practice, I'm going to put brackets around that b as well. Minus 2 times 2b times a b, and I must take the cosine of 180 minus x plus y. This will be 4b squared plus b squared minus, we have talked about this multiplication story. I cannot multiply 2 by the 2b and then the b again. You just actually just go multiply signs, multiply numbers, and then you will be done. So this has to be a 4b squared. Now, let's quickly discuss cos 180 minus x plus y. If you remember your reduction, and this is the one thing that I like about 2D trigonometry, because it brings your geometry and your trigonometry together with your algebra as well. So if you remember, we said cos 180 minus theta is minus cos theta. That's what we said. So I want you to look at this whole thing, the 180 minus the sum of x and y, as theta. So we can then see that this cos 180 minus the sum of x and y would become minus cos of what? Of x plus y. And I have deliberately left this negative in the bracket so that you see, I'm about to multiply these two negatives so that you see where the plus comes from. Obviously, 4b squared plus b squared is a 5b squared. So negative and negative is a plus. Then finally, I've got a 4b squared cos of x plus y. Just look at this, guys. We are almost at our destination. We have arrived now. Right. Then, all I'm going to do now is to factorize. And I want you to pay attention. If I factorize here, okay, let's just create more space. I can actually factor out a b squared. So if I factor out a b squared, I'm going to be left with 5 plus 4 cos of x plus y. Remember, this is what bc squared is. So when I look for bc now, I take the square root, and taking the square root, let's maybe put it on show. That's 5 plus 4 cos x plus y. Remember, square root of a times b is the square root of a times the square root of b. Surds, grade 11 surds, right? So square root of b, I can actually split this up. This is one thing. I'm going to take the square root of that. Then I will take the square root of that. So when I take the square root of b squared, I will have a b. But then because this 5 plus 4 cos of x plus y is not a perfect square, I will keep it inside the square root. Just like you would keep a 3 inside the square root. Now, my job is to substitute. Remember what we said. We said AB is BC times tan theta. So now that we have found a suitable representation of BC, we have to take this now and substitute it there. So watch. AB is equal to B square root of 5 plus 4 cos of x plus y times tan theta, which is exactly what they asked you to find. And just like that, we are done with the proof. So guys, in a nutshell, just know when to use which rule. Know when to use sine rule. Know when to use cosine rule. Know when to use area rule. Secondly, your biggest weapon in difficult questions like this, or scary questions, it's not difficult, I'm sure you've seen that. Scary questions like this, your greatest weapon is to look out for the common side. So please, look out for the common side. In this case, you saw how the common side BC made life such a joy for us. in dealing with this particular problem. I want to see if I can get one problem for you to try out. Um, so we're going to have some good reduction here, sine 2 theta. Um, I think this one will be good for the grade 12s. So let's try it. Grade 11s, try it also. If it's gonna require double compound angles, it's fine. I'll help you in there. So what I'm gonna do is I'm gonna leave this question here for a few minutes. About we have what? This is 3, 7, 9 marks. So I'll give you about 10 minutes to try this question, and then I'll come back after that 10 minutes, and I will do it with you, so that you just gauge how ready you are. Some of you are saying you're writing an SBA tomorrow or on Friday on 2D trig, the sine and cosine rule. So this should be one lesson to see you through that. So now test yourself. Test yourself. You in grade 12 also check. Are you ready for paper 2? So I'm gonna pause. Well, I'm not gonna pause, but what I'll do, I'll just mute myself or at least lower my volume, and then you try this out. In exactly 7 to 10 minutes or so, I will come back. This will also be a good time for you to stretch or use the bathroom. Okay, guys, we should be done now. It's not a difficult one, except that the first question really starts on a bad note. I think this was meant to be angle TUG. Yeah, because angle TUV is this angle here on the inclined plane, and it would really take some heavy effort to get to that. So it's not worth the 1 mark that they have allocated. My apologies on that one. So if we use sum of angles in a triangle, we will note that that angle is just 2 theta. All right. Then next up, you are supposed to show that TG is K sine 2 theta. So you need the side K, you need the side TG. Clearly, you have to work in the right angle triangle in this case. There's no debate about this one. So you got to go in triangle TGU. The following is happening. If I want to link up this adjacent and the hypotenuse, I have to go cos of 90 minus 2 theta is TG, the adjacent, over K. However, we know cos 90 minus theta is a call for co-ratios, so that has to change to a sine 2 theta, and that's TG over K. Guess what? K sine 2 theta is equal to TG. That's your 2 marks. That's how easy it was. And then thirdly, show that TV. All right, let's add this new information to the diagram. So we know this side here is K sine 2 theta. So we want to show that TV, which is this side here, is K cos theta. Please take note that we've got 2 sides, 2 angles. And of course, there is side angle, but there's no need for you to try the cosine rule here when the sine rule is very much easy and straightforward. So you can look at this as a side angle situation or a side angle situation. So I'm going to go TV over sine 150 is equal to, obviously, I need a K in my solution. So I must take the side TG, which is K sine 2 theta. And I must divide this by a sine theta again. Now, TV will be equal to sine 150 times K times sine 2 theta all over sine theta. Now, grade 11s, of course, you got stuck there. But if you're in grade 12, you know your double angle formula. Sine 2 theta is 2 sine theta cos theta. Sine 150 is a half because it will reduce to a sine 30. So that's a half K, and then we're going to go 2 sine theta times cos theta, because this is what sine 2 theta will become, and this is all over sine theta. The beauty of this, ladies and gentlemen, watch. A 2 times half is a 1. Sine theta will divide sine theta, and indeed you are left with K cos theta. So we have shown that TV, the side TV, is indeed K cos theta. Lastly, we want to show that the area of the triangle TGV, the triangle in the horizontal plane, is 2K sine 2 theta. Okay, that's another fun. Let's try that. You'll pardon me, I actually didn't read through, but I hope you did read through that opening statement. There's nothing we have missed, fortunately so, in this case. All right, so we've got side angle side, surely. Our side will be k sine 2 theta, and the other side will be 8 units, the GV, and the included angle will be 150. So area is a half k sine 2 theta, that's the one side, times 8, that's the other side. And then we have to take sine of 150. Well, 150 degrees. So grade 11s, you should have been able to do this one because you don't have to simplify the sine 2 theta. Let me actually put it to you that 8 times a half is a 4. And we already know again sine 150 is a half. Please, I'm going to try and say this very slow. You cannot multiply this angle by the half, guys. You can't. You got to leave that as it is. The half actually goes with the 4. So you got to multiply it by the 4. Okay, and an angle and a constant are two different things. So 4 times a half is a 2. So there we go. We have our area as 2k sine 2 theta. All right. So this is the long and the short of two-dimensional trig. I'm so sorry. I know I had said I'm going to do Euclidean geometry, but 2D trig seemed to be what was more relevant and needed by the majority here. So yeah, well done, guys. Thanks for joining in. We will meet again. I'll let you know on the next live.